All right, now that we have talked about empirical formulas, we can go ahead and talk about molecular, which use the empirical thing, but there's another step added to it. So basically what we're going to need to do is find the empirical formula and then compare it to the molar mass that I tell you of the compound, and then we might need to multiply something to get to the molecular formula. Keep in mind that empirical formula is the simplest whole number ratio of all of these. So say you have 4 carbons to 4 hydrogens. Instead of writing C4H4, the empirical formula would be the simplest ratio. So you're just looking at CH4, okay? We're trying to go the other way. So maybe we did reduce to get to the empirical. We don't know. We want to try to figure that out. So if we start looking at the molecular formula example in part 9, number 1, we are looking at the problem here that says we have a compound that has a mass percentage of 40% carbon, 6.7% hydrogen, 53.3% oxygen with a molar mass of 60 grams per mole. What is the empirical molecular formulas? Okay, so we're going to start, you always start doing the empirical, which is what we just worked on. So carbon, I have 40. I'm just going to write this out a little quicker here without my units. So if we go ahead and multiply or divide those, we're looking at 3.33. Now we've got hydrogen next. So hydrogen, we have 6.7. The molar mass of that is 1.01. Go ahead and divide those. We're looking at 6.63. And then we have oxygen. So oxygen, we know we have 53.3. This is a 5 here, divided by 16. Okay, so if we go ahead and divide that out, we are looking at 3.33 again. Look at these 3, find the smallest of them. Just so happens 2 of them have the same 3.33 number. So we're going to go ahead and divide them all out by this. Okay, so that means this is 1. This is 1 because that's itself. This right here is right about 2. So that means that I'm going to abbreviate it as our EF now that we have 2 formulas. So the empirical formula we're looking at is 1C, 2 hydrogens, 1 oxygen. Now we need to find what's called the formula mass. Okay, that's the molar mass of this thing because it's the formula we just found. So just like molar mass, same thing. We add up carbon, 1 of them, 2 hydrogens, oxygen, so 12, 1, and 16. You add those up, you're looking at about 30 grams per mole. Okay, now we need to compare that to the molecular mass given you in the problem. The molecular mass in the problem was 60. If these 2 were to match, we know we'd be good and we can kind of stop there. But since they don't match, we need to figure out what the factor is that we need to multiply the formula by. So 30 and 60, if you take the molar mass, divide it by the formula mass, you will find this factor. Okay, so it's a factor of 2. So that means that I'm going to abbreviate it as the molecular formula is going to be twice the empirical formula. So that means I'm going to multiply all the subscripts by 2. So since there was only 1 here before, now there's going to be a 2. There was a 2 for the hydrogen, now there will be a 4. And the oxygen, there's only a 1, so that will be a 2. So our empirical formula is the one up here. So we have it as this, CH2O, and our molecular formula would be C2H4O2. And that's how you find it.